Okay, welcome to my second talk today, or me in my real identity. Again, my name is Volker Lendecke. I work for SerNet, and I'm one of the oldest, earliest Samba team members. In the talk this morning that I held on behalf of Ralph, I've shown that we had quite a problem with performance regression in response to symlink races. And this is about what we have done for 4.17 and what we have to do to really finish this task. It's not finished. I mean, we fixed the most severe issues, but we still have some internal refactoring to do to fully get our pathname handling sane. Unfortunately, and I have to step in, or I have to step on Jeremy's feet. I have to do my talk again because I had asked the organizers to have Jeremy come right before me. For some reason, this didn't work out. I mean, just full disclosure, we had pretty much the same talks at Samba XP. Mine is a bit extended. And so I give my talk, and then like the first 20 minutes of Jeremy's talk was essentially the same content, but what can you do? I have to give this now, just to give you the introduction, what kind of problem we have and why that is. So I have to show my cat photos here again. Okay, symlink race, 1,354 symlink races on the CVE exposures database. What is that? The example here is, and you can easily just replicate this with any kind of application. I browse my directory hierarchy in any kind of file explorer, and you have home, photos, pets, cat. And what I want to do is I want to publish this to a public website, and like my blog or something or whatever. What I do is I take the full path of the file name. I take the full path and copy this as a text into my browser, preparing to upload. And then I press upload. I have taken this path from my explorer here, home, photos, pets, cat, copy this path, upload it via my browser. Now let's look at my directory hierarchy. This is where I have my photos, and there's more photos. I have my pets here, I have my dog, I have my cat, I have one photo, and I also recently had an insurance case with my car with a similar directory hierarchy, and 01.jpg, 02.jpg. And the cat is under photos, pets, cat, so it's here in blue. So that's my cat photo. How do I do that? I browse my directory hierarchy, and I copy the file path into the browser, and now the attacker has a few seconds to modify my file system behind my back. And what does the attacker do? He replaces my file name with a symbolic link to the latest communication with my insurance. So this would be the Linux command or an equivalent syscall server-side with some ransomware or whatever. This is the equivalent Unix command line command that would do this. And what happens then? My directory hierarchy now looks slightly different. The directory hierarchy now has 01.jpg on the right-hand side, pointing at 02.jpg in my insurance photos folder. So my browser now thinks that it uploads photos pets cat 01, but instead what it does, it uploads photos insurance car 02.jpg. And what happens? Something that I didn't want to publish on my blog. And the main point here is this could have been anything. In particular, it could have been a passwords file. Tom, you have seen this. What does Linux offer to protect against this kind of attack? That's Posix essentially. You open a file in Posix via the C function open. Open takes flags. Open, in particular, takes a flag ONoFollow, which means that if the trailing component, the 01.jpg, the last component of that file name is a symbolic link, then the open fails. That's specified in Posix. Linux implements, everybody implements this. The problem here is, and I'll have 2 more slides on this, symbolic links in earlier components will still be followed. This ONoFollow is only for the last directory, for the last file name component, which is this 01.jpg here. So ONoFollow, if I open the file with ONoFollow, I'm protected against this particular attack. However, there's a different way to attack me. And the attacker now does something else. It does not go in and place a symlink on 01.jpg, but it steps in between and it replaces the cat directory, which is an intermediate pathname component. And now my browser thinks it opens photos paths cat 01.jpg, but it is redirected again to my car subdirectory, which is a different photo. It's 01.jpg in the car subdirectory because in between I have been redirected from cat to car. And that's yet another funny photo from the internet. I hope I got the license right. Something I didn't want to publish to my blog instead of my cute cat. So we can also protect against this kind of attack. How do we do that? What we can do is we can change dir into this directory, photos pets cat. Do a cd or the equivalent syscall. Then I can just fix my position here, indicated by this little, okay, this, I am sitting here. I, as a process, am sitting here in the subdirectory. And now again, I can use the ONoFollow syscall. And now, when the attacker either removes this directory, I'm still there, so it will be still around after by Unix convention, or you can't remove it when I'm there. I don't really remember. However, this directory will still be around. And I still sit in this 0cat subdirectory, which is now named differently. So I don't paste 01.jpg into my browser. I don't paste the photos pets cat 01.jpg into my browser. What I just do is I open 01.jpg with ONoFollow. So this makes sure that this particular kind of attack, redirecting a directory component between the share root and the actual file, if they symlink that somewhere else, I'm protected because the directory moves with me, or I move with the directory. So that's the way you can also you can mitigate this different attack. It's expensive, and that's the performance regression that we found. In 4.15, 4.16, we mostly use this approach, and there are better ways. There are much better ways in Linux, or much more performant ways in Linux to do that. So what Linux also offers is the Openat-Call, and instead of doing a change dir into this directory, I can take a handle on the directory. I can open it as a number, as a file descriptor. So I open at this directory. For some reason, with some ways, I make sure that this is actually the right directory, and I can hold this number 42, which is the file descriptor for the directory. I can take this and keep it forever, knowing that I can't be symlink raised for this directory after I've taken the reference, the numeric reference to this directory. And what Linux and Posix offer is this Openat-Call. Essentially, that's the equivalent of me doing a changed into this subdirectory and opening just the 01.jpg with nofollow without having to change dir. So I can just take this reference and keep it forever, or for as long as I need it, with whatever some kind of caching mechanism. So I can take this reference and open any number of files in that subdirectory without having to face symlink attacks. Because this will always be my cat subdirectory, regardless of how it's named. It can be renamed, it can be moved, it will still be the directory I originally intended to use for uploading my cat photos. That's a much smarter way to open this, to mitigate this symlink attack. So, what are symlink races? Posix paths are prone to input validation problems. I mean, whenever you take something from the network, you need to fully validate, and with Posix paths, this is much more complex than you would think it is. Symlink races are a TOC2 problem, so I do check, hey, where is this really? Then I open using the full path, including the directories, and in between me checking and me actually opening the files, anything can happen in between. So we have ways to sanitize these paths, but because it's complicated, so nobody does it. So in Samba 4.16, we, in most of the places, did this change dir. And the most expensive part of this is, so we did the change dir. The most expensive piece is the check whether we are actually in photos, pets, cat, and not photos, insurance, car. That's the most expensive piece of this. In many places, and because this was kind of easy and the way to go, we did the change dir, check where we are, and then open with nofollow and change dir back. So work is ongoing to pass the directory handles everywhere. So open a directory, and this was one of the first things that we did is when we got a create request from Windows, we did this change dir, check, open, change dir back. We did it twice. Why is that? So we wanted to open /home/photos/cat/01. We did it for that. And just because we didn't fully convert our path handling to something sane, and in many, many, many cases in our code, for some reason, we need to look at the parent directory. And even if it's only for checking access in the parent directory. So we had to do this full check for the 01.jpg. Let me go back. We had to do this full check for the 01, and then just because it was a quick way to get this sane, we also did it again for cat, just as part of our code, because we need access to that parent directory in many, many places. And so we did it once, which ended up with, we did this whole thing twice. And this really cost performance. And that was the first thing that we fixed. Do it only once. And keep the directory around. So I will show you in straces in a minute what this actually means. So the first thing is, again, we took the directory handle and work off this directory handle. And the Linux kernel now offers other alternatives. The Linux kernel has yet another, Windows would call this Openat-X, just for an API conventional way, or X2 or X3. Linux just calls this Openat2, which is able to receive yet another set of flags. And one set of flags, one flag that Openat2 can receive is resolve no symlinks. And this is what we use in 4.17. So what does resolve no symlinks do? When you open a path and we look at photos, pets, cat 01. If you follow this whole stream here, photos, pets, cat 01 down there somewhere. If you do that with Openat-2 and follow no symlinks or resolve no symlinks, the syscall will figure out that somewhere in between there's a symlink, and it will just refuse to open this path. That's what this new flag to Openat-2 does. So for the fast path, I mean, we don't usually expect symlinks. For the fast path, we just open with Openat-2, resolve no symlinks, and when we find a symlink, we can do an expensive walk. Because we need to optimize for the common case. The common case does not have symlinks in the path, and so that's what we do. We now take Openat-2, and if we discover a symlink in between, then we do the checks piece by piece. I'll show you that in the S-traces. Okay, this is the history, and now what I want to show you is some S-traces. Okay. What is this? This is an S-trace taken from opening a file. The share root is home Lendecke temp, that's our share root. And I have opened this subdirectory, this file sub/0/1/2/3.txt. And let's go through these syscalls. This essentially is a real path essentially of this whole thing. Many calls, and if you really take a look at this, this is kind of an O to the order of n square in the number of path components. So you do an lstat on just sub 01 and so on, and the kernel has to always go through all the individual components again and again and again. So if you have a very deep path hierarchy here, this is O to the order of n square, which isn't really good if you have deep path components. But this is 4.12, which was fast. Then we do some get etc on the whole path, a stat, a get etc, and so on. And now we actually, wait a second, this is 4.12. We do our change dir. Did we do that in 4.12 already?
We did. The problem with the get exactor is
This is the point. I mean, I'm surprised that we do the change dir and already do the open-at with oh no follow.
We did that to fix the open.
Just the open, all the other call. Okay, we did that just for the open call. All the others were still racy. It was make dir that we were bugged about over. So we partially did that already for the open call. But what you see here is you see a boatload of syscalls going into the file system with the full path, all raceable. So we have many calls that do the full path, including all the components, and between any of these, somebody could race us and provide incorrect paths, incorrect information to us as Samba, which definitely is a problem. And this is, okay, we did it for open, but we didn't do it for any other call, like make dir unlink or something else, something like that. So this was our basic problem. So now let's look at what we have in 4.16. So where are we now? Basically, this is where the performance problem is. So this looks very, very similar to what we did in 4.12 initially. So we do our open-at pretty much the same way. We open the file as such pretty much the same way we did in 4.12. However, we have yet another set of these calls. And that is the performance problem that OEMs complained about. This is what I meant. We have to access the parent directory all over the place in our code. And this is the call that we first eliminated in 4.17. This adds yet another, whatever, roughly 10 syscalls, depending on the depth of the path, roughly 10 syscalls. We took a handle on the parent directory whether we need it or not, just to store it, just to have it around. Yeah, and that's what we did. It was safe for these calls. We did all these things for all the calls. For example, if you have a make dir, you could utilize this 32 as a parent directory and then do the correct make direct in that subdirectory. And this is what it's for. So we didn't really know in the place of the code whether we want to do a make dir. Let's just take the parent directory as a reference. So if we go down, we do a lot more syscalls. And for example, here we try to see, are we allowed to look at the file? This is the Posix ACL. We read the ACL, we convert it to internal, and this will always stay around. But yes, this is our open call, open path. So let's see how many syscalls we had in 4.12, 29, 4.16, 45, and this is our problem. Now, let's look at what we do in 4.17. A lot less lines, a lot fewer lines. This is really the same thing, same call, same SMB processing call. And what we do here is we receive our SMB request to open sub/1.sub/0.1.2 and open 3.txt in that subdirectory. So, and this is really just two syscalls. Here in theory, we wouldn't need this just to open 3.txt because Openat would tell us, hey, this is not a directory, but we could eliminate this. We want to figure out very early on, yes, we do have a directory here to be able to hand this over to Openat-2. But I mean, this is the big achievement that we were able to do. I mean, this, whatever, 20 syscalls down to 3 syscalls. And this is for the successful case where we just open a file for stat information and return back. And the rest of the syscall, I mean, we need to find our attributes to return in the SMB2 create call. What kind of file is that? What's the last access time? I mean, SMB2 create will have to return this, so we need to do this fstat call. We need to do our attribute read. We also need to see the ACL because we do user space ACL checks for all of this. And yeah, we got the file component and we eventually opened the real file. This is, by the way, the nice trick. We have this OPath. But what you can see here is just a very few lines with 4.17. One question here is, what happens if Openat-2 with resolve no symlinks actually finds a symlink? And what do we do on systems that don't have this flag? Because FreeBSD doesn't have that, AIX doesn't have that, whatever, other Unixes don't have that. Let's look at, and this is the nest trace I've taken on current master, which is beyond 4.17, but close enough. What do we do here? And this is also surprisingly fast. So we don't have Openat-2 telling us, or we don't have Openat-2 where we can ask the Linux kernel not to follow symlinks at all. Or alternatively, Openat-2 tells us, hey, there was a symlink in between. And what we do then is, remember, we were asked to open /sub/0/1/2/3.txt. We walk the path components one by one. So we open sub, we get a directory reference. Now we know, hey, inside sub, we have to open /0. And we do it in a way that, please, in this individual step, don't follow symlinks. So we are safe at this point. We get a handle on /0, we get a different handle. We close what we just have opened one step above here in sub. And we take this handle now and open 1. So in lockstep, open the next directory component, close the previous one, and so on. And this is really, really surprisingly fast. I mean, it's a number of syscalls, but if there's one code path in Linux that's optimized, then it's file open and close. So this is what we do when we figure out a symlink. Somewhere when Openat-2 tells us, hey, there's a symlink, this is our fallback code. And if you look at the smbd2 create specification, then you see the error code anti-status stopped on symlink. And as part of the reply, anti-status stopped on symlink, which is what Openat-2 with resolve no symlinks would give us. As part of the reply to this, hey, I found a symlink, we have to return to the client up to which point there was no symlink. And this is exactly the implementation we can utilize here. So we have to tell the Windows client, hey, we have 10 path components, and up to the third path component there was no problem. Only after the third path component there was a problem because there was a symlink. And by the way, here's the symlink target. And I have patches to use this code path here. And for example, /2 was a symlink here. Openat-2 would tell me, hey, there's a symlink. And I will be able to read that symlink and reply with the correct error message. So we now have all this infrastructure in place to get symlinks finally right. And not give Jeremy a heart attack every time he sees a symlink. Yeah?
Are you planning to expose that to general Windows clients?
Yes, of course. Of course. If you have, so the question was, am I planning to expose this to Windows clients? Yes, and my idea is to do this when we have follow symlinks equals no. Just not return e-access as we do now, but return for stopped on symlink and here go there.
Because if we return if the symlink is an absolute path, previously if the absolute path pointed within the share, we would follow this cycle.
Yeah, and my idea, so the comment was that previously, if we were if the symlink stayed within the share, then we would follow it. And my idea is really to say, okay, follow symlink equals no, and then of course do the check whether the symlink target is within the share, and I have code for this. If the symlink target is out of the share server side, there's nothing we can do. The client has no way to access this. And then we fall back to the, hey, anti-status object path not found or whatever, or name an error message. But if our symlink, be it absolute or be it relative, according to our path canonicalization, stays within the share, we just return that stuff to the client and tell the client, hey, go there. That's my idea at least.
So just to clarify, you're going to modify the symlink target.
Yes. My idea is I get some symlink target, I do a read link, I compare this with, so if it's a relative one, I just append it to the current state where I am, and I will run path canonicalization, so I will remove all ... or whatever, and see, hey, are you still within the share? Then I return the stopped on symlink. If this moves out of the share, be it via an absolute path or something, if it goes to /etc, access denied. That's the idea. Yeah, invented error message. The interesting thing is I did some tests with Windows. If you create a symlink target with // IP address /share /file. Windows will follow that on the client. Yes, yes. fsutil, whatever, enable. But still, I mean, the client has ways to follow this. And this is something we need to investigate how Windows exactly behaves.
We should talk to Microsoft about that, because especially if you're using MT11, that might be a way for an evil server to force a client to talk to. So where they
The comment was that this might open clients to exposing credentials or whatever to evil servers, and probably that is the reason why that is not enabled by default in Windows. But yes, I don't know. I don't know the reason behind that. So this is all good and nice. And now when you look at performance, can you measure what? Wait a second. These are my measurements that I did. And so what I did is I created 10,000 files. And this is exactly where this 0/1/2 and so on comes from. 10,000 files. And I just tarred it up with SMB client tar mode. 10,000 5-byte long files. So I did a tar via SMB. And I just ran smbd under the time command, just the one-shot smbd command. And so what I did then is I looked at I ignored the wall clock time. What I did is I just measured and averaged 3 runs of each of these with 4.12. How much time did we spend in user space? How much time did we spend in syscalls? And how does this compare with 4.16 and master? How does this compare to 4.12? And so for these 10,000 files to be retrieved, we have, that's all milliseconds by the way, we spent 840 on average milliseconds in user space. We spent roughly the same time, a bit less, in syscalls. And I took, because my OEMs were comparing against 4.12, we took this as a benchmark for 100%. And as you could guess, 4.16 was a lot worse. So in user space, we spent like 25% more time in user space, 22% more time in kernel space, because we just did a lot more syscalls. And this is what strace gave you. And so if I didn't look at 4.17, I measured master. And the interesting number here is we even use less time in syscalls with master just due to this nice Openat-2 resolve no symlinks call. So we should have some improvement. However, this red 116 here, this is what Stefan is currently working on. So we still spend quite some more time in user space compared to 4.12. I can only hope that 4.17 doesn't have these patches that Stefan is working on yet. I can only hope that my OEMs will be happy if they do their final performance tests with, okay, we do a lot less syscalls. But I believe this is exactly what Stefan is working on, and removing this extreme penalty that we have with the locking infrastructure that we did for clustering. This is what I talked about in my last talk. So we have to work on user space now, and we are on our way. So what are the additional tasks that we still need to do? So I told you yeah? That is with Openat-2. No, I don't have, but they are trivial to do. I mean, I can do that. I can repeat that. I know. But I mean, this is where we should be going eventually. But I mean, it should still be better. because these open slash close slash open at next step. I did some measurements for Samba XP, and I could dig up my slides for Samba XP. This is, as I said, surprisingly fast, even compared to the Openat-2. So, but I don't have real numbers. But they, I mean, as I said, they are easy to gather. So what is left? We have a lot of code in still where we have an open file handle, and we need to do some metadata operation. And the two prominent ones is removing a file. The other one is renaming a file. So in our internal code right now is structured in a way that if you look at the S-trace here, wait a second, if you look at the master S-trace, or the 4.7 S-trace, look at the last line. This 31, where did it come from? It came from here. So this is the full S-trace from receiving and then sending out the result. We open the directory, and within that directory, we open that file. Here we are. But at the very end of the request, we close the directory. And if you look at how Windows removes files, open, set delete on close, close. At the point where we need to remove the file, essentially do the unlink at 10 minutes left, right? At the point where we need to actually do the unlink at call, namely when the file is closed, we have closed this directory handle. So we have to reacquire it. And what we need to do is we need to keep this directory handle around for potential further use attached to the file descriptor. That's a larger change, so that we can get rid of our internal call non-wide link open in a lot more places. And so if you look at deleting a directory, there's even more steps when deleting a directory. I was just mentioning deleting a file. Deleting a file is trivial compared to deleting a directory, because we potentially have to walk the directory hierarchy below to remove everything. So there's a lot more stuff to be done that needs optimizing. But what we have done, I believe, is we really solved this essentially spec SFS software build doing just stat calls from Windows clients on a whole bunch of files as a benchmark. And I think that is solved. And that's basically the end of my talk. Thanks for your attention.
So, Samba will not allow absolute patches outside the shared memories of the main return destination, right?
Can I say again?
So if I open the destination, Samba will return stop don't select, right? You send the credit cache to a symlink file. So Samba will return stop don't select. Okay?
I don't understand. So, symlink. Oh, yeah, we're talking. Yeah, sorry.
Okay, so the spec says that it can be relative or absolute value.
Yeah.
So the spec allows the shared, the file to be outside the shared, okay?
I'm not sure about. So the question was, I mean, in the reply to the, or as part of the stop on symlink reply, there's a flag, hey, this is an absolute or relative symlink.
Right.
That's what you're talking about, right?
So you can point to another share.
Via this /server/share thing. But I believe that this flag saying absolute, and this is something I need to investigate. I believe if the client returns an absolute symlink back to, if the server returns absolute symlink, this means it's still relative to the share root, if it's not prefixed with /server/. But that's my current state of understanding. And relative means really what a Linux relative symlink also does. I have like 10 path components, then comes a symlink, and then I just append this. If you read, there's a whole section in SMB2 about how to deal with this error. And my impression is that if we return an absolute symlink, we just are absolute relative to the share that we are in.
Because I'm asking that because I had some testing previously one model shared and it worked on
Yeah.
So you can do that in the very similar to Optic anywhere you work.
Yes, yes. 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 If you, this is, I mean, I have tests where I did the make link. I have test Windows to Windows make link command on Windows, pointing at / server somewhere / share file. I clicked on this from another Windows client, and it did the DNS. I saw the DNS requesting somewhere in the internet.
So that would be great if Samba would handle that, like do not allow this kind of thing to work.
Yeah, but it's sending an empty link.
You have to do the reconnect again, right?
On the other server. So the overall comment is here, if we want to return this symlink error, we might have to do sanitizing there. Just not return anything with //. That's, I mean, that's the basic comment, I guess.
Internally, when we do BFS links, we actually store them as a symlink, but the symlink starts with a magic string MSDFS code to prevent that very.
Okay.
So here we do that even though we know the client is expecting a DFS referral.
So any other questions? Then I hand over either to the break or to Stefan. To the break.